Okay, what we're going to look at here are just a couple of really simple reactions and properties of alcohols. I'm going to use ethanol to sort of show you what happens with a few things, and then I'm going to look at a primary, secondary and tertiary and see if there's any difference with them. So here I've got some ethanol, and I'm going to add some cold water to that and see if it looks like it's one layer or two. And if we have a look there, we can see that it hasn't got a layer anywhere in there, not at the bottom, not at the top. So that shows us that ethanol dissolves in water, and that was that little diagram yesterday, the little dashed lines between it, showing that the alcohols can make hydrogen bonds. If we go to a larger alcohol though, it doesn't dissolve quite as well because of the non-polar end to it. Right, sticking with our ethanol, another thing that we can look at is whether it's got a pH. It's got an OH at the end of it, so what would we predict is its pH? Alkaline or acidic?
Alkaline.
Okay, let's have a look. So if we think it's alkaline, I use red litmus paper and expect that red litmus paper to turn blue. Okay, so let's see if that is indeed the case. Hopefully I can actually get it in there without it. Okay, and we can see that it stays red. So, okay, maybe it isn't the OH that it can lose when it dissolves in water, maybe it can lose the hydrogen. So let's put a bit of blue litmus in there as well to see if that has any effect. We'll wait with bated breath while I do this exciting thing. Okay, let's see if I can do that. And again, no change to the blue. So if neither of them change, what does that tell us about the pH? Neutral. Okay, what I'm going to do is just add a little bit of water just to see if actually it does react with water, because that was a nearly pure ethanol. So even with water, no change. So the solutions they make as well as the pure substance are neutral. Okay, and I'm just going to move those over a little bit so they're not too close to the naked flame. Okay, the next one I'm going to look at is a reaction, a couple of reactions called oxidation reduction. So that's going to be our focus for today. And in two test tubes, I'm going to have ethanol being heated up. So I'm going to put it in a water bath so that it's not directly next to a naked flame. And I'm just heating it up so that there's no waiting around for the rate of reaction. There's no requirement to do it really. It'll react anyway. I just want it to go a little bit faster, so I'm heating it up. What I've got, first of all, is some potassium permanganate, which is a purple solution, which I'll show you in a clean test tube. So there we go, pinky purple colour. That's the potassium permanganate, and I've got potassium dichromate. Now the potassium ions are just spectators. They're not doing anything. Potassium dichromate is an orange colour. So what I'm going to do is acidify those in just a moment and add them to my ethanol and see if anything actually happens.
Someone put on the elevator music. Good call, Matt.
Okay, so just acidify these. A little bit of, I'm going to use hydrochloric acid in this case. Okay. The reason we acidify them is that in particular, permanganate do different reactions under alkaline or neutral conditions. Okay, just get a test tube holder so that I don't burn myself here. That's a really good one. You don't have it doing it on video, you got a bad pair. Right, there we go. Okay, so my first one is going to be adding it to the purple permanganate. We'll see if there's anything that happens here. Okay, give that a wee bit of a shake. Probably got a bit much permanganate in there, to be honest, for this to go well. In fact, someone said I should have done it the other way, and they were quite right. I should have gone with permanganate into that. But we can see that the colour's faded. It's not just diluting. I'm going to add a little bit more ethanol because I have actually done that the wrong way around. Not that that's too important in this case. It will be in the next one, though. So if I have ethanol in there, it starts to decolorise it. I've used way too much of my potassium permanganate, which is why it doesn't seem to be doing a lot other than diluting the colour. For those that can't see, I'm just pouring it because I've gone way too far with manganate. Right, and it does go to a pale pink and then eventually to colourless. All right, so it loses its colour. Getting a slight brown in there too because I haven't got quite enough acid in there. All right, going to do the next one a little bit more sensibly, where I add the dichromate to my ethanol and see what happens. And this one does need heat if I want it to go fast. So I'm just going to leave it in there for a wee while. So it starts off, it goes yellow straight away. That's just the dilution of the orange colour, really. There's a little bit of a reaction happening, but it's primarily just a dilution of the colour. And then slowly, as I leave it, it'll start developing a new colour. So leave that to do that for a wee bit of time. While I'm doing that, ethanol is a primary alcohol. All right, it's carbon with the OH is bound to only one other carbon. So therefore, we would expect another primary alcohol to do the same thing. So what I've got is propane-1-ol. And we're going to see if it gets the same reactions as we had before. So I've still got a bit of my acidified dichromate there. I'm going to add propane-1-ol, which is another primary alcohol, to this. So actually a little bit less soluble. We see it sort of goes a little bit cloudy in there. I'm going to put that in here and see if it also changes colour. And in that time, we have seen that this has gone to a green colour. This green is due to the presence of chromium 3+ ions, okay, and that is a positive test for an alcohol. Now, it doesn't work with a tertiary alcohol, and the reason for that is that what's being formed here, first of all, is an aldehyde. So it's going from ethanol to what we call ethanal, where it's losing 2 hydrogen ions and it's making a CO double bond. I'll draw that up on the board shortly and hopefully be able to move the camera to see it. That double bond can't form if it was a if it was a tertiary alcohol. It can only happen if it's a primary or secondary. So it looks like they didn't have a secondary alcohol for me to use. No, they didn't. There are no secondary alcohols for me to use today, so I can't show you that it works with secondaries as well, other than showing you on the board. So we'll do that in just a moment. Okay, what I've got here are the 2 reactions we've just done, and just to show you the propane-1-ol, sorry, it has also gone a greeny colour there, a little bit bluer than the last one actually. It's actually reacted further. So in both of those cases, the alcohol has been oxidised, and we can't be sure what it's oxidised to yet. We'd have to do some further separation. But the reason that it can be oxidised is because it has the ability to lose some hydrogens. And in this case, it's going to lose this one and this one. So they come off, and this forms a double bond here, making CH3C, and there's an H there, and a double bond to an oxygen there. This is called ethanal. It's an aldehyde. We'll learn about those next year. In this case here, I can still oxidise it further. I can actually go further with this one because it's a primary alcohol. Do the same with this one. I can actually, I can actually turn this into an OH group. All right, and this will make this, which is a carboxylic acid. In this case, ethanolic acid or acetic acid, which is the active ingredient in vinegar. It's why with wine, if you leave it open too long, it actually starts smelling like vinegar. This oxidation process eventually will start happening after the antioxidants are used up. So this is a carboxylic acid. Now we learn about carboxylic acids this year. So you do need to know a little bit about those. We'll come to that later. So in this one here, again, are there 2 hydrogens that can be ripped off at once? Yes. Okay, cool. 1, 2. All right. So we're going to go to from propane-1-ol to a thing called propanal. And then again, I can put my OH in here, so I'll go to propanoic acid. And you might hear it sometimes called propionic acid. Please call it propanoic. Now, if, however, we had propane-2-ol, it's a little bit different. So let's look at that. Here's propane-2-ol. Can I take 2 hydrogens off like I did here, so in the same way.
No.
Yeah.
Yeah, I can take one off there and one off there, okay, to make that double bond around the carbon, so I can do this. So it will actually get the same observation. So purple permanganate will turn colourless or a pale pink, or orange dichromate will turn bluey green or green, okay? And so I'll make this. And this is a thing called a ketone, in this case propanone, also called acetone, which some of you might have heard of as a solvent for dissolving nail polish, for example, that sort of thing. Am I able to chuck another OH in here without breaking a carbon-carbon bond? No. So this is as far as this reaction goes, so that won't turn into an acid. That stops there. All right? So what do you need to know? You need to know that primary and secondary alcohols will oxidize so that means that they will reduce permanganate, so turn it from purple to colourless, and they will reduce dichromate, so turn it from orange to green. You also need to know that tertiaries will not. So I'll quickly show you a tertiary one. Sadly for this one I have to go up to a 4-carbon chain, but that's okay, or 4 carbons. And if we see here, I can't take 2 hydrogens off this area, or this area, or this area. So I can't make a carbon-carbon double bond, carbon-oxygen double bond, because it would have to break a carbon-carbon bond. So tertiary alcohols, you'd see no colour change. So the purple permanganate would stay purple, the orange dichromate would stay orange. So this helps us to classify our alcohols.